Hi, welcome to 3D Wonders. Today we're diving into a step-by-step tutorial with Shining 3D Inspect, a metrology grade inspection module. It's designed to turn your 3D scan data into clear, reliable measurements and professional grade inspection reports. If you want to try this software, you can request a free demo by visiting our website at 3dwonders.shop. This is part 1 of our full session. So, let's get started. This video will be a short introduction to the Shining 3D Inspect software. It will show you how the software is operated. In the beginning, we need to import our reference and measured data. To do this, click on the button and select either step files or STL files for reference. In this example, I'll import a step file of a plastic injection molded part. The scan will be imported as an STL. As usual, these scans are not aligned. So the very first step is to align the measured part to our CAD part. The first step is a pre-alignment using best fit alignment. Here, you can leave the settings as they are. A sampling ratio of 3, a maximum of 50 iterations, and a very small convergence value. Preview the alignment. After that, confirm to complete the pre-alignment. Now, the pre-alignment is done. For the actual alignment, we'll perform a datum alignment. To do this, we need to generate features and assign datums to them. You can create the features using CAD Auto Create. Make sure to check Extract Measured Feature. This saves a lot of work later on. Then simply mark the surfaces for your features. And confirm. After that, we need to assign datums. Right-click on the planes, scroll down, and select Set as Datum. Since these planes remain in the reference frame of the first pre-alignment, I'll set the datum names as X, Y, and Z. Once that is done, we can keep the screen tidy. Select the planes. Hold Control to add more. Right-click and group them. You can also rename the group. For example, planes for alignment. This helps organize the screen, and you can collapse or hide the group when needed. Next, we'll move to the final alignment. Go back to Alignments, choose Datum Alignment, and select the datums we created. Preview again, then confirm the values. As you can see, the first datum is perfectly matched, while the other two show slightly higher deviations, as expected, since real parts are never perfectly rectangular. If you'd like to hide the annotations, click on the datum alignment name, go to the right panel, and toggle the label display visibility. Additionally, you'll see an alignment matrix, which shows the movement from the imported position to the actual alignment. This is useful for automation, saving time by directly moving it using a matrix operation. Now let's hide our measured data for a cleaner screen and begin inspecting the part. The first inspection step is a 3D comparison. Set the reference data and measured data. If you only have 2 files, they'll be selected automatically. Choose the alignment. We'll keep the datum alignment. Enter the tolerance frame. Here, I'll keep it at 200 microns. For evaluation, set the maximum and minimum values. We have two ribbon templates. The first shows dark blue for negative values, green with intolerance, and dark red for positive values. We'll use this one. Preview the comparison and add annotations if needed. These are only visual markers showing the deviation at each point. Once done, add the comparison to the report. You'll see a success message. Then hide it to keep the screen tidy. Next, let's do a local comparison. This is useful for areas with tighter tolerances. Zoom in, select the surfaces, and set a tolerance frame, here. Preview to see the results, confirm, and add this evaluation to the report as well. Now, the next step is a 2D comparison. For that, we need to generate a cross-section. In cross-section, there's not much functionality, just one button. Click to generate a reference cross-section. You can't click both reference and measured at once, so start with the reference cross-section. You'll see your nominal file, and later the measured file will be added automatically. There are several methods available, for example using planes or along specified directions. Let's use reference plane number 1, which is also our x-plane, and give it an offset. Negative values are allowed, and you'll see the offset cutting plane shown on the screen. After that, simply confirm. This generates a cross-section through our nominal part. For the measured cross-section, right-click on the reference cross-section. Select Extract Measured Cross-Section from the scan. Confirm. And there we go. Now we can perform an inspection on this cross-section. Select the cross-section to inspect. Set the parameters. And you can also choose the template. There's a whisker multiplier, which makes deviations more visible. Let's increase the value and preview. Now you can clearly see the deviations, with whiskers that highlight the differences. You can add position markers as well to see the deviation values at specific points. When you increase the whiskers, the tolerance range becomes wider, making deviations more visible in the color map. Confirm the inspection. and add this comparison to the report. Then hide it to keep the screen tidy. Finally, let's add comparison points. These points are grouped in a point set. Define your points on the surface. Set the tolerance frames. And adjust the maximum distance. For example, any point further than 4 mm will not be evaluated. You can also adjust the radius of the inspection point. Let's make it a bit smaller. Mark your inspection points on the part. Confirm, and you'll get the deviation values for each point. You can also group these comparison points to stay organized. And of course, add them to the report. That's how the comparison functionality works in Shining 3D Inspect. That wraps up the first half of our Shining 3D Inspect tutorial. In Part 2, we'll continue exploring advanced features, helping you maximize accuracy and efficiency in your workflow. To learn more about 3D scanning solutions, visit us anytime at 3dwonders.shop.